Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com program, brought to you by Techstrong and Fairwinds. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, as always, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of your screen, along with a few other options. There's the chat tab, where we want you to go ahead and start warming that up now. Let us know from where you're joining, or maybe what role you play in your org. So right now, there won't be anything for you in the in the polls tab, but we will have 2 polls to launch throughout today's program, and they will remain open after their launch. So if you don't get a chance to answer it right away, please do so later in the program. And as always, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. So the topic of our conversation today is best open source policy engines for Kubernetes. And I'm joined by Robert Brennan, Vice President of Product Development at Fairwinds, Joe Pelletier, Vice President of Product Strategy at Fairwinds, and Kendall Miller, Technology Evangelist at Fairwinds as well. So Kendall, Joe, and Robert, thank you all so much for joining me today. Kendall, you want to go ahead and run away with it?
I will go ahead and run away with it. Thank you, Cody. Hello, folks, and welcome to Best Open Source Policy Engines for Kubernetes. Excited to be here with you today, and we will go ahead and dive in. So as Cody mentioned, there is Q&A over on the side. We're going to have some polls throughout. Please do punch in some questions in the Q&A if you want. Let folks know where you're from in the chat, that kind of thing. And I will try to watch questions as they come in, if that's in chat or Q&A. Q&A is where they should go. Sometimes people put them in chat. It doesn't really matter. We're usually on top of both. But I will try to answer questions as they go if they're relevant, and or we will have time at the end for questions. Let's dive in. And let's start with intros. Joe, why don't you kick us off?
Yeah, thanks, Kendall. So my name's Joe Pelletier. I head up the product side of things here at Fairwinds. So I've been working in the cloud and DevOps space for a little over 10 years now, and looking forward to sharing with you all kind of what we're learning about policy engines and how it can help your organization. Turn it over to Robert.
Hey folks, I'm Robert Brennan, VP of Product Development here at Fairwinds. I head up all the engineering efforts on our commercial product, Fairwinds Insights.
Great, and my name's Kendall. I'm a tech evangelist here at Fairwinds. Been with the company for a very long time, doing all the things, talking about all the Kubernetes with all the customers all the time. So excited to be here to talk about this with you. And real quick for some background, Fairwinds aims to be a trusted partner around security, policy, and governance. We build software to make companies successful with Kubernetes. Everybody's moving to Kubernetes. Everybody's afraid they're doing it wrong. We build software to make that easy, to put guardrails around things so that you can have confidence you're doing it right. And we have services that we also offer to help people along the way. So if you're using Kubernetes, thinking about using Kubernetes, know someone or love someone who's thinking about using Kubernetes, we probably have something that's relevant for you, be that open source, a service, or our software, Fairwinds Insights. Today, we're focusing primarily on our open source and other companies open source in this space, but we do have other offerings as well. All we do is Kubernetes, all we do is policy, and we integrate some of these things into our software. So this is a world we live in, this is the water we're used to, and we're excited to be here talking about it with you. Before we dive into the meat of the event, we're pulling up this poll. Wow, Cody, that was fast on the trigger, well done. Where are you in your Kubernetes journey? Are you learning about Kubernetes and containers? I don't know what's going on there. Are you planning to use it in 6 to 12 months? Are you? This is audio that's I like it. Are you using it only in testing and development environment, or are you using it in production? Is the poll still up? Are people still answering? Mine went away. So
yeah, no, it looks like it's still up, I think.
Okay, so you can go into the polls and select one. We do collect this data across all of our webinars, and it's useful for us to have. So please give that a second. Oh, here we go. Response is coming in. We tend to see lots of people using it in production or just learning about it rather than in between getting like planning on using it or using it in test and development. And it looks like the results as they're coming in right now are something similar. I'll give that a second more. Cue Jeopardy music. Yeah. Okay, here we go. Jeopardy. There we go. That was slow. That was like two Jeopardies playing at the same time. That was a little weird. Okay, so yeah, here we go for results. Primarily using it in production or learning about containers and Kubernetes. So glad to have you here wherever you are in the process. If you're just learning about Kubernetes and containers, get policy in place now. If you're using it in production, get policy in place now. It's like both situations. This is highly relevant to what you're doing. And we will close this poll in 5, 4.
Still coming in.
1. Yeah, they are still coming in. Okay, we'll wrap that up. And I'm gonna move on. Okay, so let's start with what is a policy engine. And Robert, you wanna take that one?
Yeah, so the idea behind policy is that you really want to put some guardrails in place for your development teams to make sure that they are adhering to best practices, that they're not doing anything that's terribly insecure, inefficient, unreliable, that they're doing everything according to your organization's standards. So that might be things like, making sure that containers aren't running as root. It might be things like setting their CPU and memory settings. It might be things like making sure those CPU and memory settings aren't going to cost you $1,000 a month. Making sure that auto scaling is enabled, all sorts of different things that it's on the individual development teams or individual operations teams to implement, and you can kind of at a high level across your organization enforce that. Policy engines can run both in a sort of passive mode where you can audit your environment or audit your infrastructure as code and see how compliant am I, how many of these policies have I adopted, which teams are really out of compliance. You can also run them in a more active mode where you can block things that don't meet a certain level of requirements.
Yeah, well, so that was a whole bunch there. I would back it up to even, because we're getting into some of the why and some of these other things, which we'll add on to. The way I think of a policy engine, it's like a governor in a car, or the thing that I use the most often, and maybe I'm holding up my hipster card here a little louder than I want to, but is those little scooters that you can ride around town. And the moment they hit 16 miles per hour or whatever that is in kilometers, it just stops going faster, right? Like you hit a guardrail. That's just the policy that keeps me from going faster.
Right.
And in that situation, it's because they've decided that's what's secure. Go ahead, Joe.
Yeah, and I think even just kind of expand on what Robert and Kendall are saying, like a policy engine in the Kubernetes context really, in general, focuses on sort of that application configuration. It can do more than that, but that's usually the key use case. And, with, developers shifting to, with the advent of infrastructure as code and developers having a lot more influence into operations, right? Configuration has become kind of a core part of the development process now, especially around getting applications to run on Kube. And so a policy engine really operates on that configuration, the manifest, whether it's in YAML, Helm. There's even, kind of Terraform type policy engines. And it really helps make sure that the configuration is following sort of the best practices. And like Kendall said, there's a bunch of reasons for why this is important, but wanted to be a little bit more clear around like it's operating on sort of that app config side.
Yeah, well, so let's talk about why. Why do we want a policy engine? I mean, I want to be able to go as fast as I can go on a scooter. Why the heck would you slow me down? And the answer on the scooter is so that we reduce the risk of death, which may seem like, maybe is worth putting some policies around. And hopefully in Kubernetes world, it's not always risk of death, although some people are running life-saving or life-dependent Kubernetes infrastructure. But why don't you start with this one, Joe? Why?
Yes. Yeah. So, the reasons for a policy, there's actually many reasons why policy is important. And in fact, we're even seeing with the Kubernetes, core project, policy making more and more of a sort of first class feature within the Kubernetes itself over time. And that's actually really good for making this easier, more accessible, more available to more and more, users of Kubernetes. But the reasons why is, I think fundamentally, organizations are leveraging cloud, Kubernetes, and containers so that they can get to market faster and ship faster, right? And there's lots of great, advantages of Kubernetes for making it easy to, run containers, manage those containers. But at the end of the day, the teams that are deploying to Kubernetes, those are typically app teams and dev teams, and their main job is kind of writing code and features, right? And so to be able to ensure that those teams can ship reliably, ship consistently, you want to be able to put, a feedback loop in place that tells them, hey, here's, a better way to configure your application, or here's a challenge, or here's a problem with your current configuration that could lead to a business impact, like downtime in the future if you don't add liveness probes, or compliance issue if you don't configure Kubernetes in a certain way. And I really think, the reasons for a policy engine are to really ensure that that goal of moving fast and shipping applications faster can be realized by organizations, so that it's not just a fragmented, every application is a snowflake in production. You want to really make sure that, teams can reliably get their apps to run without introducing risk. So that's my kind of 50,000 foot view, reason for why. I think there's a lot more specific reasons around kind of, at a Kubernetes level, why it makes sense too. I don't know if you want to weigh in there, Robert, on those areas.
Yeah, I mean, so first off, I just want to expand on something Joe said, which is that, policy, even though there is this stereotype that policy is going to slow you down, as Joe mentioned, it really does ultimately help teams ship faster because they can ship confidently, right? They know that they're not going to break anything by, writing some new configuration. They don't have to spend hours, doing research and making sure that they've crossed every T and dotted every I. They know that there are guardrails in place to make sure that they adhere to best practices, that anything they do ship is going to be secure, efficient, reliable, and all that. So ultimately, if policy is done right, it should be making your teams move faster. In terms of
go ahead, Robert.
So I was just going to say, in terms of why in Kubernetes, I would say that the big thing is Kubernetes is just, it's a very complex ecosystem. There's a lot to learn. There are people who make their entire career these days off of just being experts on Kubernetes, and you can't expect every developer or every development team to have a Kubernetes expert on it. And so you really need some kind of guardrails in place, some kind of help in place for those development teams to make sure that they're able to ship, confidently.
Yeah, and to go back to my scooter analogy, which I do intend to wildly overuse throughout this webinar, if you put 100 people on scooters and let them go as fast as they want, the reason we have governors on them is we know that when people are going too fast, they tend to crash. And 100 people don't get to where they're going if they all have to stop and wait for the ambulance. And if you slow them down a little bit on the front end, they all get there safer, faster, better, more often. That's the reason that policy exists. Everything in infrastructure is a trade-off, and a policy engine is one more of those things. Let's put in place a few guardrails so people can do less right now and cause less damage.
Yeah, and Kendall, actually, if you go back just one slide, I want to make just one more point there. What we hear a lot, especially with companies going from kind of proof of concept stage with Kubernetes to really expanding a multi-tenant Kubernetes strategy, which really might mean multiple apps or multiple teams on a single cluster. It's really that governance of making sure that the shared resources in that cluster are not going to be interfered with while individual app teams configure their workloads to do what it needs to do, and continue kind of normal operation of the cluster, so that it's not one team impacting the issues of another team. And I think what we have found is as different as different companies go after multi-tenant strategy, that you find that there's different teams are at kind of different levels of learning around Kube. And so one team might be following practices that are different than another team. And it's sometimes it's because configuration is being copy and pasted from team to team, right? So you might potentially be, propagating forward a lot of these bad mistakes. And so a policy engine can help you prevent those issues as early as even the pull request phase all the way into production. I think that's where we're going to kind of share a little bit more around the integration points, et cetera.
Yeah, well, so let's talk about what makes one great, because today we're going to talk about great, best open source policy engines. We're going to get into some of the specifics of the ones that are out there. But let's talk about what makes a great policy engine, because I mean, there's an awful lot of policies we can write. There's an awful lot of places to implement them. All those things, Joe, that you're touching on.
Yeah.
And, do you want to start in this one again, Joe?
I'll start. Pass it over to Robert. I think there's a lot of things that we've learned after releasing Polaris, which is our open source policy engine, around kind of what makes a great, reliable policy engine. And I think we're seeing that organizations are really looking for something that's easy to use, that can get up and running and be applied at various different parts of the life cycle. We do have some considerations around policy engines. I think being able to run in a shift left context, so kind of scanning policy at the earliest phase when YAML code is being written or Helm charts are being written, all the way through to the runtime or the cluster, auditing your existing workloads to make sure that they are aligning to best practices. Robert, I want to see what else you have found in terms of what makes a great policy engine.
Yeah, I would say the big thing is finding something that can start small and grow with you, right? You want an engine that's going to be fairly easy to adopt, especially at the beginning. Policy can be very complex. So having an engine that has an easy syntax to work with, or some out of the box policies that you can just implement on day one is super helpful. But you also want some support for custom policies so that 6 months from now, when you have a new requirement, you want to adopt a new labeling scheme, whatever else, you are able to start implementing those new policies within your existing policy engine.
Yep.
I want to emphasize those couple of things. The easy to write, because there's an awful lot of things out there, cough, Rego and OPA, which we're going to talk about in a second, that is just difficult for people to get to. The learning curve is high, and they're super powerful, but if it's so complicated to adopt out the gate, people never get there. And it's like the world's best collaboration tool. You can't get anybody to use it. It doesn't matter, right? Because if the learning curve is too high on the front end. And then I really like the out of the box, some sane defaults are something that we see people request a lot and say, something that's a key differentiator. It's one thing to open a box that enables the most incredible policy enforcement in the whole wide world, but there's no examples, and you're new to Kubernetes and you don't know what you're doing. So you don't even know what should be a policy. So it's nice to have some out of the box. Go ahead.
Yeah. Yeah, no, I was just going to agree with you there. And I think it does come down to trade-offs between each different, there's different types of policy engines out there. And there's no one that's absolutely perfect for all organizations. I think, to your point, though, there's different trade-offs around kind of ease of use and speed versus, the specific policy enforcement use case you're looking for.
Yeah.
As an employee of Fairwinds, I believe that Polaris is the perfect policy engine in all situations. Joe, what is this? No, I'm just kidding. Go ahead, Robert.
I was just going to say, I think it is important to highlight this last bullet point, though. I'm running in multiple environments. A lot of times the first place you'll want to start applying policy is just like looking at your live environment and seeing, okay, what resources are in here that don't meet my requirements. But pretty soon you're going to want to take a step back and say, okay, now that I've fixed a lot of my existing issues, stop new ones from getting in. So you might implement an admission controller and make sure that anything that's coming into your Kubernetes cluster, for instance, gets stopped if it doesn't meet those policies. And then shifting even further left, being able to audit infrastructure as code so that people are getting feedback as they're making a pull request before they merge into the main branch. Getting stopped right there at the time of code review so that they can fix those issues really, really quickly. One of the most frustrating things as a developer is when I ship a change and then 2 days later, somebody complains to me hey, your change broke this thing. It doesn't adhere to best practices. It's causing the security issue, whatever else. Now I have to go back in and change it again. I really want that feedback as quickly as possible.
Yeah, before you get there. Okay, so policy engine considerations. We've talked about what makes a great one. We've talked about that already. But Joe, this sort of lays out a couple different places that policy engines are that they integrate, how they work, all the different things you need to think about in a policy engine. It sounds like it's just a press button, slow me down when I hit 16 miles per hour. But there's actually quite a bit more than that. Dive into it.
Yeah, so I think what I wanted to try to do is break down.
We lost you, Joe.
Joe, we just lost your audio. Still muted. Maybe your headphones died.
I'll take over for Joe in the meantime.
It's okay. Yeah, go for it.
So yeah, a policy strategy is a super complex thing. There's a lot that goes into designing a good policy engine, designing a good, basically internal strategy for deploying those policies across your organization. So the first thing is, what do you want to test for? Are there security issues, reliability issues, consistency issues, et cetera? Just figuring out what are the policies we need to put in place. Do you have a need to be SOC 2 compliant, PCI compliant? You might have specific policies for those things like that. I think, also looking at, if you're evaluating policy engines, just like figuring out which of the engines that I'm looking at come with these built-in policies and will support the policies that I want to apply here. Once you've got that kind of world of policies that you want to apply, figuring out where and when they should apply is super important. So maybe you have policies that need to be applied in production, but don't need to be applied in your development and staging environments. Maybe you want to apply these policies on infrastructure as code, but you don't necessarily want to enforce them in every single production environment in case there's a break glass kind of situation and an operations engineer needs to go in and make something run as root, for instance. So figuring out where those policies should apply, should they apply to system level workloads versus application workloads, things like that is very important.
And hang on a second, Robert. Joe, it looks like you've moved upstairs.
Try to get close to the Wi-Fi.
Again.
Yeah.
Is there anything that you'd add to? You didn't maybe hear all of what Robert said, but
no, I think I got the grasp of it. I think at a very high level, it's just kind of breaking down policy, what does it actually mean? There's the logic around the policy, right? What are you actually trying to check for in that app configuration, which I'm sure Robert addressed. There's also the scope. Policy doesn't necessarily need to apply to every single resource. It may only apply to groups of resources like app teams versus cluster add-ons. And I think the other area is just the integration points, which I think I'm sure you talked to Robert, around shift left versus admission control or runtime.
This is where we left off, actually.
Okay,
so
perfect.
If you want to go into that, go ahead.
Yeah, so I'll just jump right in. So I think, around the integration points, it really comes down to, where do you want to provide that feedback, right? The goal of integration points is to get developers and get DevOps engineers with the feedback around, policy issues as early as possible. And, a great policy solution will integrate as early as the pull request, so like a CI/CD integration, all the way through to the runtime and admission control, where you can actually, even what's called mutate, resources, so that you can even change files or change configuration from, one configuration to another along the way. The fourth category that I think we wanted to introduce here, though, is automation, which is really around what do you want to do with that policy violation or that policy once it's triggered. And Robert, do you want to share some examples there?
Yeah, so some things you might want to do once one of these policies get triggered is maybe send an alert to Slack, open up a ticket in Jira. You might want to open up a PagerDuty alert if it's a critical vulnerability, like someone's trying to mine Bitcoin in your production cluster, that might be PagerDuty incident worthy. So having these integration points, for your policy engine where it can reach out to other systems where your engineers already live is super important to make sure that they have eyes on when bad things are happening, and B, they're taking action. It's holding folks accountable by opening tickets and things like that is super important.
Awesome.
Okay, great. And glad to have you back, Joe. So interesting. You moved upstairs. It's so much more light. It's so exciting. Okay, so we do have a couple of example policies to go through here to talk about what kinds of things go into a policy engine. If you've attended one of our other webinars where we dig deep into some policies, some of these might be familiar to you, but it's helpful, particularly if this is your first one, to have a feeling for what kinds of policies are out there, how they're enforced, what the problem is, what the impact is. So let's start with over-permissioned containers. Robert, if you want to dive into this one.
Yeah, so once you have your containerized application, you want to ship it into Kubernetes. Kubernetes gives you a lot of options for, basically the security options around this container. Some workloads occasionally do need access to the underlying node that it's running on. Most of them, especially your application containers, probably don't need these things. And so it's important to make sure you're setting the security context around your workload to basically pare down as much of that security permission as possible, so that if there is a vulnerability in your application and an attacker gets inside that container, they can't escalate into the root node and like spread across your entire environment. So making sure that your containers aren't running as root, for instance, is very important. Making sure they don't have unnecessary capabilities to do things on the host system. Making sure that the file system is read-only is great, because now they can't download any extra scripts or anything like that. There's a whole bunch of extra security context you can provide for these containers. Some of it's on by default, and you just want to make sure people aren't turning it on. Like you want to make sure people aren't adding new capabilities to the workloads. Some of it is on by default, like you are allowed to run as root by default, and you may want to add some extra security constraints saying, I want to make sure that for every single workload running in my clusters, we've turned run as root allowed off.
Yes. And I would say that this is a common type of policy that you'd put into sort of application namespaces, where you want to, by default, new teams running in a multi-tenant cluster, adhere to security best practices by default, and then kind of enable certain security features like running as root if it's only absolutely needed. So it's a way to kind of ensure that you're kind of secure by default, from a Kubernetes perspective when deploying workloads to new namespaces or to application namespaces.
Great. Let's look at another one. An efficiency example: inappropriate resource requests and limits. Talk about that. Who
Yeah.
Joe, you want to take that one?
So I'll jump into this one. So I think the common, this is actually a pretty big problem in Kubernetes, where, again, going back to who's deploying apps to Kube, it's typically application developers who want to get their applications to run as quickly as possible so they can keep moving forward with new features. And the general problem that we see in this space is teams might over provision their workloads. The other flavor or problem is they may not even set memory, CPU or memory requests or limits at all. And that's where you can apply sort of some initial guardrails to make sure that there are settings in place, or at least ensure that the values that are being submitted fall within certain ranges that are considered appropriate. So there are some ways that you can guarantee that these resource requests or limit are being set at a minimum or falling within certain ranges. I think there's a big opportunity in this space to do a lot more around making sure that resource requests and limits are correctly set. And that's where I think you're going to see some innovation among policy engines, applying even more sophistication around setting the correct values for workloads.
Yeah, I'm muted. Great. Okay. And then, well, hang on a second. Before we go into another specific, I want to clarify that, like, some of what we're talking about here: security, efficiency, reliability, right? We're talking about 3 pillars in Kubernetes, things that we all care about. We want policy around all of them. Just policy around security, nice to have, need to have, probably. You don't want things deployed in it that are insecure. But it's not enough if you can't scale reliably, if things fall down, or you're spending millions of dollars and putting your business out of there's ways to lose money. One of those ways is to deploy something that's insecure and have somebody hack in and mine all of their Bitcoin on your cloud. Another is to spend so much without knowing it that you put your company out of business. And so all of these things do really go hand in hand. They're really sort of baseline. We're giving you 3 categories to think about it. But it's back to my scooter example. You need wheels that meet a certain standard. You need metals that can support a human body that's going to stand on it. There's lots of different pieces that go into it. It's not just keeping you from going fast. And I will come back to that at least once more. Go ahead, Joe.
Yeah, no, I think it's spot on. And from our experience, I think there's actually a lot of security use cases that folks gravitate to initially when it comes to policy, because of the importance of making sure that Kubernetes is secure by default, that it is compliant. But we also see that there's just as large number of just kind of reliability and efficiency and general best practices, like requiring labels and making sure you have things like liveness and readiness probes, which I'll let Robert kind of dive into a little bit here.
Yeah, so liveness and readiness probes are really a way for Kubernetes to tell if your application is healthy or not and is ready to serve traffic. It's super important for Kubernetes to know that, so that it knows if it should maybe try and restart your workload, if it should start serving traffic. So for instance, if you deploy a new version of your application, what Kubernetes is going to do is it's going to keep the old version up and running until the new one spins up and reports, hey, I'm ready for traffic. If you don't have these readiness probes set, Kubernetes is just going to immediately start sending traffic there, even though it hasn't like connected to your database yet. And you're going to have, maybe 30 seconds of downtime as a result. So making sure you're setting these things is super important. Kubernetes won't complain if you don't set them. It will just, happily spin up your workload and try to serve traffic to it. And, it's just kind of on you that you messed this one up. So having some kind of guardrail in place to make sure that your development teams are doing this, even though they don't necessarily have to, from the Kubernetes perspective, is super important.
Great. Yeah.
I need to stop muting myself. I normally don't mute myself. I did today a couple times. So we do have one more security example, denying vulnerable containers. And go for it, Joe.
Yeah, so I think this is actually a fairly sophisticated example, right? I think out of the box, it's going to be, you may not find a policy engine that supports this use case on day one, potentially. So to kind of shine some light on this example, you have a application configuration that says you need to pull a certain image at runtime, and that image may contain vulnerabilities, CVEs that range from critical to low in terms of severity. But there has to be this pre-step to scan that container or get the latest vulnerability report for that container, and then making decisions as to whether or not it needs to be deployed. And so this is kind of an area where you're going to see policy engines go from more basic scenarios of making sure certain configs exist to more advanced scenarios where it brings in outside data to help ensure that you're evaluating more than just the configuration to make policy decisions. So it's a little bit of an example of where we see policy going in the future, and how you can how policy engines can kind of take in outside data sources to make even more sophisticated decisions that ultimately improve security, or just make developers' lives easier by not having them, do additional steps along the way. So just wanted to highlight that as a potential example.
Great. Anything to add, Robert?
No, I think Joe nailed it.
Okay. Okay, great. Well, so let's talk about getting started. So there are a couple of well-known open source policy engines that are out there. There's Polaris on here, which obviously it's our child, so it's the only beautiful one in the world, and everybody else's child is not as beautiful. But we want to talk about the other ones as well. So OPA and Kyverno are two of the big players that are out there. And let's talk about the differences between a couple of these. What makes Polaris stand out a little bit, but what are the advantages of OPA and Kyverno as well? And let's get into the nitty gritty. This is about the best open source policy engines. Here's the slide talking about the three key leaders in this space. Who wants to kick us off?
I kind of want Robert to help us understand these. I would just first say, I think all three projects actually do a great job in terms of making policy more accessible to Kubernetes users, right? These are all very well-maintained projects. And I think you're going to find that there's different trade-offs around depending on what you're looking for, right? At the end of the day, we're seeing, I would say, kind of lots of adoption of all three of these, depending, again, on the use case or the type of organization that's looking to apply guardrails. We did wanted to, expand on some of those key considerations around like other, common features across the different policy engines. And that's where I'll let Robert kind of highlight a few of the critical ones here.
Yeah. So like in terms of these kind of baseline features that you should be looking for in any engine you pick, one is just this ability to write custom policies. There are some not listed here that will just check for, 10 pre-built things. And, that's kind of all you get. If you want something that's beyond those 10 things, then you're kind of stuck. So having some kind of flexibility, some kind of ability to customize policies, to write brand new policies, I think is very important. Also having a public policy library is a very important aspect of it. You don't want to be writing every single policy from scratch. Pretty much every major engine has either built in some policies like Polaris, or they have enough of a community around them where people have posted some policies on GitHub, things like that, which you can kind of pull into your environment. The other thing you should be looking for is this idea of admission control. So not just looking at my environment and saying, what is and is not conforming to policies, but actually being able to block things at the time of admission or even mutate them at the time of admission and say, okay, you tried to create a workload with image pull policy set to if not present, we always want it to be always. And so we're just going to change that for you without giving you any kind of warning or anything like that because it seems safe. So having that mutating admission controller is also a good kind of baseline feature to look for.
Yeah, and the one other thing I'll highlight is, and this is one of the areas where Polaris starts kind of differentiating is this ability to not only just make it easy to understand what are the issues in my cluster, like install and get a dashboard that multiple teams can look at and understand what are my open issues, but also the ability to kind of shift even as far left as possible and automate fixes to the underlying YAML code by ensuring that if you do have a misconfiguration that the developer has accidentally coded in, can you be able to kind of automatically fix that with a policy engine as well? And I think this innovation around fixing and accelerating that kind of remediation stage is going to be an area that we'll see more activity around.
And then I think it is worth mentioning that OPA is intended to be a very broad policy engine that is not specific to Kubernetes exclusively. Whereas Caverno, am I wrong about that? Caverno is specific to Kubernetes. Polaris definitely is. But it's because of the specificity and the focus that Polaris has that allows you to have the preloaded baseline policies out of the box. And I think it's worth us sharing like some of the context for the reason Fairwinds is in the policy game at all. And as I mentioned, this is all we do. Even our commercial software does this. This entire thing is not intended to be like just a wild, sales pitch for Polaris. It's open source, so there's no sale that needs to happen. You can go download it and install it. We also implement OPA into our commercial software because we recognize that's another standard that people do like to leverage. But I think it's worth saying that we exist as a policy-focused, guardrails-focused, security, reliability, efficiency-focused company in the Kubernetes world because our genesis is as a service organization that was building and maintaining Kubernetes clusters for lots and lots of clients across all three major clouds. And we found through doing that, everybody runs into the same problems. Everybody has the same questions. Nobody realizes that, these few basic things are common policies and common practices that they need to have enforced across the organization. And their engineers definitely don't realize it. And so we end up seeing the same kinds of problems over and over and over again. And that's why Polaris has preloaded baseline policies, best practices that we know everybody gets wrong because we've seen it. So that's part of why that exists the way that it does in Polaris.
Yeah, and I think we're going to actually do a quick demo too of Polaris to kind of highlight what you said, Kendall, and I don't know if we have a poll question before or after that. I forget.
We got another poll question before. So I think it's worth touching on just a few more points before we shift that way. But OPA is a CNCF graduated project. I mean, did we go through this specifically? Caverno's in CNCF incubating. Polaris is not a CNCF project. It's something that we still maintain ourselves. But these three are out there in these different spaces, getting different kinds of backing. You probably need a policy engine the same way you probably need a governor on your scooter. Okay, I'm all done. Let's go to the next polling question. Let's pull this up. What's your greatest opportunity for improving your Kubernetes environment? Is it getting help with the basics? Is it a general best practices assessment? Is it improving the security posture of your clusters, saving money, or improving the reliability of apps running in Kubernetes? Spend a second. Oh, here we go.
Here comes the demo.
It's like almost Jeopardy, but I think it's not, probably for copyright reasons, but it's so close. It really does encapsulate the spirit. And let's see how that poll's coming through. Okay, yeah. So on our Kubernetes journey, we are seeing lots of people are. Oh, I'm sorry. I was looking at the previous one. The greatest opportunity to improve. Looks like we're seeing pretty even across things, except improving the security posture of your clusters, which makes sense.
Yep.
This is the thing. If you're worried about the security posture of your Kubernetes clusters, and you should be, getting a tool in place that is focused on the policy to keep bad things from happening, rather than just being aware when bad things have happened, is really a key step, especially in large, mature organizations. Writing policies so that people can deploy things, are empowered to deploy things that are up to the standards of your organization is key.
Yeah.
So we'll leave that open for another few seconds. Any comments on this, gentlemen, before we move on?
No, I think the only comment is it totally makes sense that this is kind of the opportunity that we see a lot of organizations pursue next. I think improving security of Kubernetes is a multifaceted thing. Policy is one part of that. And so I think, we're going to see more and more of a need, as companies go from that kind of POC stage to running in production, right? Even at the earlier poll, it looks like about half the folks here are running in production. The other half are trying to get to production, right? And so that's something we're going to see even more and more of a need of in the next few years.
Yeah. Okay, and it's worth saying Fairwinds helps with all of these. So if you're interested in any of this, please reach out. We're happy to help. We've got something that helps somewhere along the way. Again, either an open source project, something you can pay for software-wise or service-wise. And with that, let's move on to a Polaris demo. And Robert, I'm going to turn it over to you to pull up your screen and show people what Polaris looks like and talk through that.
Right. So I'm going to start my terminal here. Just show you how easy it is to install Polaris on a Kubernetes cluster. I'm just going to do this helm install command. That's a little further along. So just helm install Polaris. I'm installing it in this namespace, Polaris Demo. We'll kick this off. And voila, I've got some commands I can run here. I can do a little port forward and just check out the dashboard as it's running here. So I'm going to run that port forward. And I'm going to switch real quick over to my browser so y'all can see what Polaris kind of looks like out of the box. Fairwinds.
And this is on your cluster running on a bunch of Raspberry Pis in your basement, right, Robert?
Right. Yeah. So this is a kind cluster, which is running on my local workstation here. So it's got some toy workloads in it. You're not going to see very much. It's not really like a production cluster, but you can see I've only got 2 nodes here, 12 namespaces. But you can see pretty quickly at a glance, I'm doing okay, right? I've got 220 passing checks, got a handful of warnings, and then like a few dangerous checks that I should probably dig into here. But for the most part, Fairwinds is giving me a B+ here. I'm happy with that overall. So if I scroll down, I can see, okay, what's going on by category. I've got a few efficiency issues, some more reliability issues, very few security issues, but some of them are actually pretty dangerous. So we can maybe dig into what's going on there. As I scroll down, I can see like, okay, most of this is looking pretty good. If I look into specific namespaces though, okay, I can see Cert Manager. I do have some problems here, right? I have a Cert Manager workload. It's only got 1 replica scheduled. That could be a reliability issue. Image pull policy is not set to always. Again, potential reliability issue. I can dig through here and just see, what's going on. I can see KindNet has some of these bigger security issues, but I also know KindNet is a system level workload. It really does need a lot of these extra permissions. So I might use Polaris to create some exemptions for these and say, hey, actually just ignore KindNet. It really does need the host network. It really does need privilege escalation. So you can leave these behind. I'll jump back to my command line now. Cool. So we have seen, a bunch of findings within the cluster. Maybe we go in and fix some of those things, but we want to make sure that we're not, introducing new findings into the cluster now that we've set up a good baseline. So the next thing we can do is reinstall the Helm chart and set this webhook.enable true setting, which is going to enable the validating webhook. And so this is going to block workloads from getting into the cluster if they do have problems. Now I have this test deployment. You can see it's got really just one issue here where it's allowing privilege escalation. So if I do I'm going to do a delete first, just to make sure it's not in there. If I do an apply on this workload, you can see Polaris comes back and says, hey, you've got this container Nginx. It's got privilege escalation allowed. You're not supposed to do that. So if I come in here and fix it, say false, I can try and apply that workload again, and Polaris lets it through. So this gives you a way to block specific things that are coming into your cluster that might not adhere to your requirements. You can configure exactly which things block, which things don't, etc. So if there are certain checks you want to maybe escalate to blocking, or certain checks you just want to let through, you can configure that with Polaris. If we reset here, the other thing we can do is say, I have this infrastructure as code file. I want to see just, quickly without applying it to the cluster, what are the issues that Polaris finds in here? I can run Polaris audit, pass it this file that I'm looking at now, and I can see, exactly what's going on inside of this file that I should maybe take a look at. So I can see, in addition to this privilege escalation allowed warning, there's some other warnings around, like I'm missing memory limits, missing CPU limits, I'm missing liveness and readiness probes, missing memory requests, things like that. So I've actually got a bunch of problems here with this workload. Say I want to go in and fix these. What's really neat with Polaris, something that we've added very recently, is this Polaris fix command. So again, I can pass it this file name. I can say I want to fix all the checks that Polaris knows about. And if I do a little git diff here, you can see, okay, so it's set privilege escalation to not be allowed. It's added multiple replicas here. And it's even fixed some things that, maybe require a little bit more context. Like it's added a readiness probe, it's added a liveness probe, it's added CPU and memory limits, but it's also added comments saying like, hey, you're going to need to change this readiness probe to reflect your application's readiness to serve traffic. You might need to pull an API endpoint, something like that. Same thing for CPU and memory settings. These might not be appropriate settings for your workload. They're pretty normal baseline settings, but you might need to go in and say, I actually need a gig of memory. I actually need half a CPU here. So that gives you a quick way to just, start making progress against your infrastructure as code files. I think that's all I've got.
Okay, so we are going to move to a time of question and answer. And if you have questions, there is a Q&A tab. You can go type that in. It stays anonymous, so you don't have to be fearful if you're typing in, hey, everybody I know and love hates policy. What do I do? Whatever your question is. So I think the right question to get started on here is just, where do I go to get started? How do I choose between OPA, Kubernetes, and Polaris? If I'm new to this, do I go install all three and kick the tires? Like, where do I get started? Obviously, Robert, you showed us that Polaris is the easiest and the best, and of course the most awesomest, and that's the obvious solution. But if that's not the case, or I'm not working at Fairwinds, where do I go to begin?
Yeah, the nice thing about the fact that they're all open source is that you can try them for free, right? You can install them all in a test cluster, in a kind cluster, in your staging environment, kick the tires, write a few custom policies, see how it goes, and see what each one feels like, see what they're good at, see what they're not good at. Our bias is obviously for Polaris, but like I said, they're all free to try.
Yeah, and I think just to expand on what Robert's saying too is, a great way to start is just by auditing your existing cluster. Just get a sense of what's going on, in the cluster today. Are there any obvious policy violations or obvious best practices that you want to enforce? And so, picking the tool that can help you get that information quickly, it might be a great way to start. And then, from there, when you want to go and enforce policy or push it out to the rest of the team, that's where I think you can discover the different trade-offs or the different options in the space. Like Robert said, they're all open source. There's great documentation around each of these tools. And I think, we see a lot of folks, experimenting with policy, and, as a way to kind of, move their program forward.
Great. Any other questions folks want to ask? You're sitting there attending this because you're thinking, hey, someday I'm going to need to enforce policy in my Kubernetes clusters. So now is your opportunity to ask what you do next, where to get going, how to get going, why to do one thing over another. Give it a minute, just long enough to be a real awkward silence, which of course I'm going to fill with constantly talking. Okay, well, no questions coming through right now. That's okay. And Cody, we can turn it back to you to wrap us up.
All right, sounds good, Kendall. I'm going to give away some gift cards, and then we'll check back in on those questions. So the 4 winners of our $25 Amazon gift card drawing are Mohammed E., Kathy S., Rick D., and Jeremy A. So keep an eye on your inbox to claim your gift card, but if you don't happen to see that email, do check your spam folder. And I'll also remind everyone that this session was recorded. So should you want to rewatch or share with a friend, you will be receiving an email with a link to access this recording on demand, or you can find it living on the Container Journal website at containerjournal.com/webinars. All right, not seeing any more questions coming in. Kendall, anything else before we close out, or you want me to just go ahead and take us out?
I mean, do you have a song that you can play while we leave, or is Jeopardy the only one? I feel like
that's the only one I practiced.
Dance. Oh, come on! Wait! Oh, here we go. Before we go, there is one more question. What do most people write policies about to control apps? Robert, Joe?
Yeah, I would say it's a combination of I would say there's like a handful of best practices that get implemented across all organizations, and you'll find those kind of built into Polaris or as part of the public policy libraries for some of the other policy engines. That's things like not running as root, setting liveness and readiness probes, setting memory and CPU settings. Those are kind of just like standard, baseline expectations for pretty much everything in your cluster should have CPU and memory settings. There's very rarely a reason to not do that. The one thing that I will say, once you start getting into custom policy, things you're not going to find in a library, is usually around like a labeling scheme. So like making sure that every application has like a cost center code labeled on it, making sure that they all have a team label, an owner label, something like that, so that you can, figure out, if an application is causing problems, the operations team knows who to reach out to, knows who to bother about it.
Yeah, I would definitely agree with that. I think there's definitely this concept of policies that apply to all workloads, and then there's some that apply to sort of the namespace specific or tenant specific that, might even kind of increase the scrutiny around what is allowed to go into that namespace, such as additional security considerations or default to a strong security posture, and then kind of create exceptions from thereafter. And so I think it does depend on whether it's kind of a core infrastructure workload or something that's more related to the app layer, and that's kind of generally how we see things segment out.
Okay, and with that, thanks y'all. Thanks so much, Cody. Thanks, Techstrong, and reach out if you have other questions or want to. Oh wait, I did have a final screen here that I should have been sharing for a call to action. If you want to go check out Polaris, we have a website for that here. And it's just GitHub/Fairwinds Ops and Polaris. And yeah, I mean, I should have touched on our commercial software does integrate OPA, Polaris, etc. Fairwinds Insights is the name of that. And I didn't hit share on this screen like I thought I did. There we go. Okay. And you can check that out too. So if you have Kubernetes policy needs, reach out to Fairwinds. With that, we'll let you go. For real this time. We'll really let you go. For real. Thanks,
awesome.
Cody.
And of course. And so Fairwinds will also be sending you a post-program email with this link attached. So you'll be sure to get this, whether you want it or not. But Joe, Robert, Kendall, thank you so much for being here with us. I'd like to thank Fairwinds for sponsoring today's program. And to our audience, we really appreciate you spending time with us as well. We really value your time, but we also value your feedback. So as soon as we close out, there should be a survey that pops up on your screen. We'd really appreciate you filling that out. Let us know what you liked about our program today, or maybe what you'd like to see in future programs. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, and to our panel, thank you once more.
Thank you.